Hi there, we're gonna learn how to derive E equal to gamma mc squared. So using the work energy theorem, W equal to Fx, which is force times distance, we're actually going to use calculus to derive this equation. So we're going to do work equal to the integral of 0 to x f dx. And there are some formulas that we need to know. So F equal to dp over dt. So again, we're using calculus, so that's why it's dp over dt instead of just p over t, a small change. And gamma, of course, is 1 over square root of 1 minus v squared over c squared, which is also 1 minus v squared over c squared to the power of negative 1 over 2, just to make it more easy. And we also need one more formula, which is the relativistic momentum, P equal to gamma mv. Now we're going to start off with the formula dp over dt. We're going to expand the momentum formula, so it's d gamma mv over dt. The rest mass is constant, so we're going to take the m out and then do d over dt. Put the rest in brackets, so 1 minus v squared over c squared to the power of negative 1/2 and v. That equals, we're still going to keep the m constant, so we're going to do m in brackets. We're going to use the product rule and the chain rule. So we're going to keep this constant and take the derivative of the other. And now we're going to use the chain rule. So we're going to keep the v constant, and according to the power rule, nx to the power of n minus 1, we're going to take the negative 1/2 outside, and then do the exponent minus 1. So we're still going to keep the 1 minus v squared over c squared, and negative 1/2 minus 1 is negative 3 over 2. Times the inside part because of the chain rule, so that times negative 2v over c squared. We're just going to keep it c squared because c is the speed of light, which is the same, so we're just going to keep the c squared. Times dv over dt. Which equals m. So I'm going to take the dv over dt out because there are dv dt in the previous equation, so I'm just going to take that out. 1 minus v squared over c squared to the power of negative 1/2 plus v squared over c squared, 1 minus v squared over c squared to the power of negative 3 over 2 because of this, which then becomes m dv over dt 1 minus v squared over c squared to the power of negative 3 over 2. Okay, now I'm going to show you how I got to this from here. So let's go to the bottom. So I'll show you. So from here, we're going to do 1 over square root of 1 minus v squared over c squared, because 1 minus v squared over c squared to the power of negative 1/2 turns into this, plus v squared over c squared. I'm going to put this in the denominator, so that becomes 1 minus v squared over c squared. Square root in the denominator, 1 minus v squared over c squared. Now I'm going to multiply the denominator by both c squared and 1 minus v squared over c squared here, and the same for the numerator, so that becomes c squared minus v squared c squared minus v squared plus v squared, and keep all of it up in the denominator. That becomes c squared 1 minus v squared over c squared square root of 1 minus v squared over c squared. These all cancel. These cancel. All we're left off with is 1 minus v squared over c squared to the power of negative 3/2. So that's how this works coming from here. And that's when we come back to this. So all I showed you was how from here we got to here, and using that we're going to come up with the formula for kinetic energy. And again, we're using integrals and calculus. So the integral of 0 to x, which is distance in this case, we're going to keep the n, and then from the previous equation, 1 minus v squared over c squared to the power of negative 3 over 2, and dv over dt, and dx. And the integral of 0 to v, 1 minus v squared over c squared to the power of negative 3 over 2 v dv. Okay, I'm gonna erase this and continue on with the KE equation. So as long as we got that. Which is a continuation of the kinetic energy formula. So we left off with KE, kinetic energy, equal to n, 0 to v, 1 minus v squared over c squared to the power of negative 3/2 v dv. Now using that, we're going to use the chain rule again, so we're going to give the inside part a variable. So off to the side, I'm going to do u equal to 1 minus v squared over c squared. We're going to make du equal to negative 2v over c squared. So we're taking the derivative of the inside, we're going to keep the c constant, times dv. And now we're going to keep the v dv equal to negative c squared over 2. comes from this equation. So since we've set variables, we're going to make the math more easier and more organized. So we're going to do KE equal to M integral of U, which is 1 minus V squared over C squared. Let's not get to there yet. Let's just use the variables, which is, and then times negative C squared over 2 times du. We're just plugging it in here because this is v dv, and we're just plugging in negative c squared over 2 du instead of this, in place of this, yes. Which equals mc squared. There's mc squared, so I'm bringing this outside with the m. 2. And since this is the integral, instead of the power of nx to the power of n minus 1, we're going to add the exponent, use the exponent plus 1, and divide that answer. So we got negative 3 over 2 plus 1 is u to the power of negative 1/2. And divide that by negative 1/2. Because we're doing integral here, so it's the opposite of the power rule. And the negatives cancel, so we're left off with mc squared in brackets 1 minus v squared over c squared to the power of negative 1/2. And because it's an integral, we're going from 0 to v. And now we're going to use the first theorem for integrals, which we have learned in calculus. So using the kinetic energy formula, we're going to do mc squared gamma minus 1. And let's do some distribution, so that's gamma mc squared minus mc squared. And because of that reason, we're going to do some rearranging. So we're going to bring this to the other side, so that becomes gamma mc squared equals mc squared plus ke. This is kinetic energy. Just label these. So this is kinetic energy. This is rest energy. That's why we always kept a constant in our derivation. Rest energy. And this, of course, gamma mc squared is our total energy, according to Einstein's mass energy principle. Just write that out. There we go. So that's why this is the total energy. And then we get E equal to gamma mc squared. And that's our final answer. And this is how you derive E equal to gamma mc squared. Thank you for watching.